Hi, everybody. Welcome to lesson 2, in which we play around with more quadratic functions. Specifically, we're going to be looking at standard form quadratics, which is what we've been working with, ax squared plus bx plus c, the parabola where the polynomial is written in standard form from highest exponent to lowest. So you have x squared, plain old x, and then a constant term. So to start us off, find the zeros of this quadratic equation by factoring. So we have to factor this. So I'm going to ask myself, what multiplies to negative 40 that adds to 6? What two numbers multiply to negative 40 that add to 6? Well, one's positive and one's negative. 2 and 20, no. 4 and 10. 10 and 4, the 4 is negative. So 10x, negative 4x. So my factors, this trinomial factors as x plus 10 and x minus 4. Those are my factored. So I took standard form and I turned it into factored form, which gives me solutions of x equals negative 10 and x equals 4. Those are my solutions to that quadratic equation. That's what we focused all on last unit, was how do I solve that equation. So now we're going to look at what does that mean about the graph. So let's graph that trinomial, x squared plus 6x minus 40. So let's go to y equals. Let's go to y equals on our calculator. Grab that on out. X squared plus 6x minus 40. And it should be a parabola. How do I know it's a parabola? It's got that x squared term. Ooh. So I don't see the full parabola because it's zoomed in too much, but it goes on my graph there. It's on the graph there. It goes up and down and forms that nice U shape there. So what's the important part here? What are the x-intercepts? Where do I hit the x-axis? Well, 4, 0. And it looks like all the way over here at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Looks like over there at negative 10, 0. So this should look familiar because, wait a second, aren't those my zeros? The x-intercepts are actually my zeros. So I don't even ever have to solve a quadratic equation. How can I solve a quadratic equation? I can solve a quadratic equation by looking at the graph and finding the zeros. I can use my graph to solve any quadratic equation now. So we've got factoring, we've got completing the square, we've got the quadratic formula, but now we add another tool which uses technology, and that's graphing. We can solve any equation by looking at where does it cross the x-axis. The x-intercepts are where I cross the x-axis. They tell me the zeros. The zeros are the x values. The zeros are those x values of where I cross the x-axis. So that's a huge idea when we work with parabolas. We can find our solutions to an equation by seeing where it crosses the x-axis. So in the last lesson, we learned that graphs are symmetric. So if I know the x-intercepts, I know it's at negative 10 and 4. Those are my x-intercepts. How do I find the axis of symmetry? Well, he's got to be in the middle. He's the average of the zeros. He's in the middle. He's the average. So how do I average them? I add them up and divide by 2. I average my zeros to get the axis of symmetry. So I got the middleman is negative 3. X equals negative 3. X equals negative 3 is the axis of symmetry. And how do I use the axis of symmetry to find the vertex? Well, we plug it in. If I know the axis of symmetry, I know part of the vertex already. The axis of symmetry is the x-coordinate of the vertex. We get the y-coordinate by plugging it in. We plug it into x squared plus 6x minus 40. That's how I can get my axis of symmetry. So x squared plus 6x minus 40, where I plugged in a negative 3, I get negative 49. I got negative 49 as the vertex. And if I go to y equals here and look at my table, I should see that exact same thing. Remember, when we look at our table, we want matchy-matchy. We want people to match up. There we go, 24, 24, 33. Who's in the middle there? Look in the middle of the table. What do you see? Negative 3, negative 49. What do we see here? -3, -49. So I didn't have to do any of that work there. I could have just used my calculator, but I want you guys to understand that the axis of symmetry is in the middle. It's in the middle of your two zeros. Once you find your zeros, you can go back and find the middle. It's the average of the two zeros. To find the axis of symmetry, you average, add them up and cut it in half to find that axis of symmetry. So like I've said before, the x-intercepts are the zeros. They're the roots of a parabola. So find the zeros of this function. So I could use the quadratic formula. I could complete the square. I could factor. Or, wait a minute, I could just pull out my calculator and type it on in. 2x squared plus 20x plus 48. I can already find my zeros just by looking at the graph. Where do I hit the x-axis? Well, 1, 2, 3, 4, -4 and -6. So the zeros are -4 and -6. I could go to my table, second table, find the matchy-matchy, make sure everybody matches up. That's what I have to do when I work with parabolas, x squares. I got to match up. Where are my zeros? -4 and 6. When do I equal 0? Those are my zeros. Or we could have factored. We could have factored here. It's actually not that bad, which is why I'll do it. What multiplies to 24 and adds to 10? For those of you that are quick at factoring, it's x plus 4 and x plus 6. So I get x equals -6 and x equals -4. Because if I want to know the zeros, I set it equal to 0. So there's multiple ways to solve these quadratic equations. So if this is g of x, find me the roots of the equation. Well, let's do that. Let's go to y equals to find our roots. 2x squared plus 5x minus 42. So I might not see the whole parabola, but it's there. I might not see up there it is. There's part of it. It's not two lines. This is actually that U-shaped parabola. It just goes down really far that our calculator basic screen can't see it. And I don't feel like messing around with our calculator right now. So I got one of them. 1, 2, 3, 4, 5, -6. I got x equals -6. But this other one looks like a decimal, doesn't it? 1, 2, 3. My guess, I think 3.5, but I can't just guess. I would say 3.5, but I don't know. So let's factor this to solve. Let's factor this to actually find the zeros. Or you could use the quad formula if you'd like. I'm going to factor, though. What multiplies to -82? Actually, you know what? I don't feel like doing this. Let's quadratic formula. X equals -b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And then we type in that there. 5 squared minus 4 times 2 times -42 is 361 square rooted. And I'm going to type that into my calculator and hope it becomes a nice number because I'm pretty sure it is. It is actually 19. This is actually a perfect square. I kind of guessed there that it would be one. -5 plus 19 divided by 4 is 7 over 2, which happens to equal 3.5. Or we get -24 over 4, which is -6. So notice my guess was right. The zeros are -6 and 3.5. I can use my graph, or I could use factoring, or I could use the quadratic formula. I want you to understand that relationship between solving and graphing. This takes everything we did last unit and connects it back to this new unit. So pause the video and graph me this function. That means you actually have to plot points. So go to y equals and plot me those points. You better have paused it. I know you didn't. You're waiting for me to do it for you. Pause the darn video and do it. You still haven't paused it, have you? For those of you who did, thank you. So I'm going to go to graph. Oh, there's my beautiful parabola. And I'm not just going to freehand it. I'm going to go find the matching in the table. I'm going to go find those matching values in the table there. Nope, nope. There we go. So these are the values that I need to plot. These are the values. Let me just drag it over here. These are the values that we need to be graphing. There we go. I'm not going to graph those guys because those are too big. So -1, 4, 0, -1, 1, -4, 2, -5. And now watch, I'm going to use symmetry because I hit the turning point there. That matches up there. That matches up there. I'm not even looking at the table. I just use the symmetry of the graph. So my questions are, what are the zeros? Well, there they are, but I have no idea what they are. I don't see them in my table. They look like crazy decimals. So that means I've got to do some work. I could either use the quad formula, but in this case, I'm going to actually complete the square. I'm going to complete the square just so we practice going through all these techniques. Cut the middleman in half. X times x, -2 times -2 is +4. So that's the magic number I need to add in is a +4. But if I add in 4, I also have to subtract 4. Well, how does this factor? This factors into x minus 2 squared minus 5 equals 0. And now I can use little inverse operations to find the actual value of those zeros there. Find where do I actually hit the x-axis. I'm going to add 5 over, take the square root, plus or minus radical 5, and then finally add the 2. So notice I got an irrational answer. We can't actually figure out the irrational numbers from the graph, but I can actually solve it to find the zeros. So sometimes you have to do a little bit more work. Unfortunately, everything from last unit is still in play right now. So let's talk about the Y-intercept, and then we'll move on with our lives and call it a lesson. So we've been talking about X-intercept, zeros. Where do I hit the X-axis, right? The X-intercepts are the X-axis. We're used to the Y-intercept. The Y-intercept is where do I hit the Y-axis. So find the Y-intercept by finding f of 0. We find the Y-intercept by plugging in 0. Not when it equals 0, when I plug in 0. 0, 0, I end up getting -1. F of 0 is the point 0, -1. Which, wait a minute, go to this graph here, what do you see? 0, -1 is where it crosses the y-axis. So, in general, we find the y-intercept by plugging in 0. But watch what happens. If I'm in standard form and I plug in 0, well, 0 squared is 0, so that's gone. That's gone. So it's the constant term. The constant term, just like it is in linear functions, the constant term is the y-intercept. The constant term is the y-intercept. That number stuck on at the end is the y-intercept. So if I go back here, what's the y-intercept of g of x? -42. Done. What's the y-intercept of f of x? 48. Done. If I want to know the y-intercept, I just look at the constant term. So that's going to just be a helpful piece going forward with these standard form parabolas. We can find the zeros by graphing, factoring, completing the square or quad formula. And if we need it, we can quickly find the y-intercept just by looking at the equation. Done. It's the constant term. That's where I hit the y-axis. See you guys soon.